Hello everyone. In this video, I want to discuss a low-level design of a parking lot management, which is a scalable and modular approach to vehicle parking operations. In real-world example, customers in parking lot face difficulties in finding available parking spots, keep track of their parked vehicles. Manual ticket systems are prone to error and delays affecting the customer satisfaction. An automated solution that offers easy vehicle entry and quick payment options is required to enhance the parking experience. In this approach, we allow vehicles to park and generate tickets and additional services that like car washing to the tickets and the process of exit requests and calculate the charges as per the hours they are stayed in the parking and accept the payments cash or online transactions. In this approach, we have created 5 files that are parking lot, parking spot, vehicle, and parking ticket and service layer. In the low level design, we have included object oriented principles in this low level design approach for the parking lot. We have included that encapsulation, abstraction, inheritance, and polymorphism. This is the overview of our low level design for the parking slot. Now we will see the implementation of the code. Let's start with the main method. The main method serves as the entry point for the parking lot systems. It provides a user-friendly menu-driven interface to interact with the system. The method performs the following key functions: display the menu options, handling the parking, and add the car services and exit from the parking lot. Now as we see that we have imported all the classes which we have created in the files as the import by using the import method, and then we have initialized the parking spots as in the main method. Here we can see that inside the while loop we have written the how the output display of the parking slot. We have used the switch case method for the cases. The case 1 represents the parking of the vehicle and case 2 represents the add the car wash and the case 3 represents the exit from the car parking slot. And it is all about the main method which we have created for the parking slot in the low level design. Now we will see the implementation of all classes one by one. First, let us we see the parking spot class, which is an abstract class. It represents the parking spot in a parking lot, which contains the attribute ID, is free, and floor and amount. And the key methods we have included in this: cost, is free, set free, and we have used get ID and set ID for the retrieve of the ID from the class. And we have created an abstract class that is cost in the last. And let's go to the second method, payment services. In this parking slot we have created a payment service method for the payment for according to the hours stay in the parking. And here we have created a public void accept cash method for the acceptance of the cash. And for other methods, debit card and online payments, we have created another method for the called credit card for the payment. And later we have created the parking slot class, which is represent the parking lot and manage parking spots entrance and exits. It contains the attributes entrance, exit, and the display board and free parking spot, occupied parking spots. And we have method calls get instance and get free parking spots. We can observe that the variables are declared in private and class also declared as private. And we have created the initialize the parking spots. And later we have used get name get set name for the retrieve of the data from the class and set the values for that variables. And later we have created the parking service IAMPL class for handling the parking related operations such as vehicle entry, exit, and parking tickets management. The key attributes present in this parking strategy ticket. And we have added the key methods entry, exit, add observe, notify all observes, and the add wash methods. Continue.
Now we see the vehicle class. So the main purpose of the vehicle class is represents a generic vehicle. So it has an attributes which is a ID, which is a unique identifier for each vehicle, and park spot enum, the type of the parking spot that vehicle requires. So it also has some key classes like car, truck, motorbike. So which specializes the vehicle classes that extends vehicle and specify their required parking spot types. Example, car uses compact, truck uses large. Now the another class is parking ticket class. So the purpose of the parking ticket class, which represents a parking ticket issued when a vehicle is parked. So it also has some attributes like vehicle, parking spot, and a unique ID. That means unique ticket ID, and it some has some methods get ID. So it returns the unique ticket ID. It also has some getters and setters because the instance variables are declared in private. So the another class is parking event class, which represents events that occurs in the parking lot. For example, vehicles which is entry or exist, and it has some attributes which are event type. It represents the type of the event which is that is an entry or exist, and another attribute is parking spot enum. It represents the type of the parking spot related to the event, and the remaining all are the getters and setters. So now another class is an admin class. Its main purpose is to represent the administrator of the parking IoT system. It has an attributes which are parking lot. It represents it is in reference to the single ton parking lot system. The admin class, it represents the administrator of the parking lot system. It has some attributes parking lot. It represents a reference. The invalid ticket exception class. So its main purpose to custom the exceptions for handling invalid ticket scenarios. Methods, it has in methods. It has in methods. So the method is mainly used to for invalid ticket exception. So it is a constructor that accepts an error message. The display service interface, it defines the contract for updating the display of the parking system. It has in methods update, update which updates the display with the number of free parking spots of a specific type.
Hi everyone, I am the third person in my team. Today I came here to present our project focus on designing a low-level implementation of parking lot management systems. It handles the core functionalities like parking spot allocation, updating display boards, and managing parking spots dynamically based on the real-time events. The key concepts. So the key concepts what we use is in these are parking the parking slot allocations and updating display boards and managing parking spots dynamically based on real-time events. These are all where plays a crucial role while we placing a car in an automatic machineries such as in orbit malls and major malls we can use this type of activities. So now let us see how can they allocate the spot and how can they update the display boards and how can they manage parking spots dynamically. The key concepts for these three are, first of all, parking spot service. It is an interface to define the contract for parking spot specific implement. What we need to implement that is a presence in a class parking spot service implement. Ensure consistency by requiring a create method to generate parking spots. When parking spot service that creates a method to generate parking spots. So while we can to create any spot mean we can need to create a spot in parking spot service. That is an interface for parking spot service implementation. It is parking spot service implementation is a class implements the parking spot service interface. What the methods and what we create, what the spots are created in a parking spots interface, it can be implemented by parking spot service implementation. The purpose for creating is creating parking spots dynamically for different types, compact, large, etc., and assigning them to specific floors automatically. If we need to enlarge means we can nowadays we are level floors of cars flora storages to store to put the cars in an uh, i- uh, we have a floors to put the cars. So for that we need to give the compact large etc to assign them as a specific floors. What car we need to give in a what floor. So we need to have we need to specify them features that are uses replications to initiate the approximate parking spot subclass based on the parking spot enum. It can uses to replication to initialize the approximate parking spot. What the accurate parking spot that can be given, it can be uses as a replications to instant it as a parking spot, and it can be storing in a parking spot enum. Updates the free parking spot count via display service. The display service what we have that can be stores and updates by using this parking free spot, and it counts as and it counts as is shown in a display sort services. This is the major class what we have seen, and the observer can be only seen in a display service implement class. This class implements what the user can see. The implements the display services and observer interfaces. The purpose of this means updating the display boards with the number of free parking spots based on the parking events. What the events that are actually occurring in a car parking, that can be counts as an display services. We need to update the display services to get the better interactions. So the what the logically have the logic behind this display boards is when a car is entering to an garage, it can reduces the count of a frequency, and when we exist it can increases the count. So it can uses the display board. By using display board we can easily show what the free pace what we're having in an ad. While we using interactions with a user, vehicle entry, user can enter a parking lot and that specifically finds a available parking spot based on the vehicle type. If he uses a car, it can allocate a space within a space which can specify it is a car space or not, and if enter a truck, it can specify and truck space is available or not. By availing the spot, it can generate user a parking lot. A parking ticket is generated with the details of vehicle and parking spot. Vehicle exit. Users can exit the parking lot by providing a valid parking ticket. The system calculates the parking fee and allows the user to pay. While we entering that parking spot, the user can generate that ticket. While we exiting, we need to show the ticket, and it can generate ticket prices. So we need to pay the fee to allow the user to exit. The car wash service enhances the system by offering optimal add-ons to the users. The service is implemented using the decorator pattern, allowing flexibility without modifying existing classes. Flow of the car wash services are: when a vehicle parks, a parking ticket is generated. If a user requests a car wash, the add wash method updates the parking ticket. The car wash added attribute is set to. Now we will see the output for the above implementation. Here we can see we have added three values: park a vehicle, add a car wash, and exit from the parking. Now let us enter for the parking. It will allocate parking ID and the spot. Now let us try another option, that is add a car wash. Now we have to enter our car ID and type of the vehicle. It shows that successfully added to the car wash for the car ID. And now we'll try for the third option, leave a car. Suppose we have entered a wrong ID 2. It will show that is invalid. It says that there is no car in that spot. And here is the final output of our code implementation for the low level design of the parking lot. Thank you.